Hello everyone, I am Sajitha, faculty of Silver Hills Public School, Calicut. I am here to discuss the chapter States of Matter in Science, Class 4. We are surrounded by a number of objects. So many things you can see around you, right? Trees, the books which you read, the air which you breathe in, the food we eat, the toys which you play with. You know, all these substances are made up of matter. So let us explore matter. How will you define matter? Before learning about states of matter, it is important to know what is matter, isn't it? So first let us define matter. Anything that has mass and occupies space is called matter. So anything that has mass and occupies space. When I am standing here, I am occupying this space. When you are sitting somewhere, you are occupying that space. So we ourselves is a good example for matter. Anything that has mass and occupies space is known as matter. Now, as you know what matter is, it is easy for you to understand the different states of matter. Let us see what are the different states of matter. Matter can exist in three different states. First one is the three common states of matter are solids. In solids, ball, the mobile phones, the book, all these are examples of solids. Next one is liquid. Liquid means the water, the juice which you drink, the milk, oil, all this come under the group of liquids. Then comes the gases. Gases means what? See, the air which you breathe in, oxygen, carbon dioxide, all these are coming under the group of gases. Now, let us see in detail why some objects are known as solids, some are known as liquids, and some are included in the group of gases. That is what we are going to learn next. See, what is in my hand? I have a ball in my hand, isn't it? The ball is occupying the space in my hand. So when I am putting the ball in this bottle also, the ball is occupying the same space. And again another thing is that there is no change in the shape of the ball. Ball is round in the shape when it is in my hand or whether it is in the bottle. In both these cases, there is no change in the shape or the space occupied by the ball. There is no change in the shape, isn't it? When it is in my hand or in the bottle, the ball is having the same shape. So first property of a solid is that it is having a definite shape. Another thing is that it is having a definite volume. You know children, what do you mean by volume? Volume is the space occupied by a substance. That means when the ball is in my hand or whether it is in the bottle, it is occupying the same. There is so much of space in the bottle, but still the ball occupies the same space only. So solids have a definite shape and have definite volume. Another important thing about the solid is that why they have the definite shape? Because the particles in a solid are very tightly packed. That means the particles, which every substance is made up of smaller particles. So these particles which make up the solid are closely packed, and there is a great force of attraction between the particles in the case of solids, and they are not free to move anywhere. So how can you define solids? See, solids, the particles are tightly packed. Hence, the particles cannot move around. That is why solids have a definite shape and they have a fixed volume. See, this is how the particles in a solid is arranged. So, in solids, the particles are tightly packed, they are not free to move, and the force of attraction between the particles is more than in liquids and gases. So, they have a definite shape, size, and a fixed volume. So, one state of matter, I hope it is clear to you. Now, let us see about what is happening in the case of liquids. Why some substances we are bringing under the category of liquids. Now, what is there in my hand? I have a glass of water. See what is happening. I added just a little ink to the water so that you must know the level of water in the glass. Now, this water which I am having in the glass is in the shape of this glass itself. Right? Now, when I am pouring this liquid into this bowl, what is happening here? It is taking the shape of the bowl. And another thing also, how much water is included in this bottle, the same water I am pouring into this, but there is so much space, but it is occupying only this much space inside this bowl also. What does it mean? It is having a definite volume. That means it will occupy the same space whether it is in a small glass or whether it is in a big bowl. And another thing is that the liquids do not have a definite shape. It is clear from this experiment. When I am pouring this into this glass, it is taking the shape of the glass. And the same liquid, when I am pouring into this bowl, it is taking the shape of the bowl. So what did you understand from this? Liquids do not have a definite shape. As in the previous example, I showed you the ball. When the ball I am keeping in the bowl or in another vessel also, it has the same shape. But here what is happening? The liquid changed the shape from the shape of the glass to this shape. What did you understand from this? Liquids do not have a definite shape, but they have a fixed volume. Even though this much space is left for the liquid, it is occupying the same space as it needs when it is in the glass also. So from this it is clear that liquids have a definite volume, but they do not have a definite shape. Then why liquids are not having a definite shape, you know? In liquids, the particles are not so tightly packed as in the solids. That means they are free to move, not too much. There is a force of attraction between the particles, but still they are not so tightly packed as in the solids. So they are free to move. That is why we say we include such substances in the group of liquids. Now in liquids, the particles are not very closely packed and thus can move around. See how the particles are moving? Liquids do not have a fixed shape but have a fixed volume. So they can flow from a higher level to a lower level. See, this is how the particles of a liquid behave. As you already learned about solids and liquids, now the third category, that is the gases. In gases, the particles are very loosely packed as compared to solids and liquids. And I cannot show you a gas, isn't it? What is the shape of the gas in this room? In the shape of the room itself, if you are filling air in a balloon, what is the shape of the air? It will occupy the whole space inside the balloon. That means the gas particles are free to move anywhere. It will occupy all the available space. So gases do not have a definite shape and do not have a definite volume also. In the case of gases, this is not the same case as in the liquid, because in gases the particles will occupy all the available space as much as it could. So gases do not have a definite volume. It will not have the same space. When there is more space available, it will occupy the whole space like that. So we say that gases do not have a fixed shape and they do not have a fixed volume too. See, in gases, the particles are very loosely packed as compared to solids and liquids. So, gas particles can move freely in any direction. They have neither a fixed shape nor a fixed volume. See the particles of the gases, how they are moving? They are so far away and they will occupy all the available space. So, that is the difference between the solids, liquids and gases. So, it is clear to you, I think, why some substances are called as solids, some as liquids and some as gases. The differences between the solids, liquids and gases. See, this is the difference in the particle arrangement. In the case of solids, liquids and gases, see the difference. It is how they behave also. Solids, the particles are very closely packed. In liquids, there is space between, but still there is a force of attraction. In the gases, it is not like that. They can occupy the whole available space. That is the difference in the particle arrangement of solids, liquids and gases. Differences between solids, liquids and gases. First point, solids have fixed shape and volume. Solids have fixed shape and volume, but in the case of liquids, they have fixed volume but no fixed shape. Then in gases, no fixed shape and no volume. They will occupy all the available space, and so there is no definite shape. Here, the very less space between the particles. In the case of solids, as I showed you in the slide before, particles are very close to each other. Here, more space between the particles than in solids. There is space but not as much as in gases. More space space than in solids. In gases, what is happening? Space between the particles is more than in solids and liquids. So in gases, the space between the particles are more than solids and liquids. Then the solids cannot flow. They will remain where you are keeping it. Then but the liquids, they can flow from a higher level to a lower level because the particles are not so tightly packed, and the gases can flow in all directions. So these are the differences between the three states of matter. Now what is happening here? See the ice. Ice, I have taken this is a picture of ice which is just taken out of the freezer. What is happening here? The ice. After some time, the ice is changing into water. Right? When you keep the ice out of the freezer for some time, what happens to ice? It gets converted into water. What is happening here? That is what we are going to learn next, about the conversion of the state of matter from one form to another, and what is the name of such processes. Now here, as I told you, ice is getting converted into water. How ice is? If you are keeping the ice in the freezer itself, will it get converted to water? No, not at all. This is happening because since outside it is very hot, the particles of the ice, which is a solid, will gain energy and they will start vibrating, and the space will be created between the particles, and finally they will be freed from the force of attraction because they are getting energy from the outside, since it is very hot outside. So what happens is that slowly they will get converted into their liquid form. When the space comes between the particles, naturally that is the property of a liquid only. In solids, what is happening? The particles are very tightly packed, but in liquids, what happens? There is space between the particles. So here, when you are taking ice out of the freezer, then the ice will get converted into water because the particles will gain energy and they will start vibrating, and the space will be created between the particles, and at that stage they will get converted into liquid. And the same water, when you are taking it back and keeping it, or any liquid, if you are keeping it back in the freezer or inside the refrigerator, what is happening? Freezer inside the refrigerator, on cooling, what happens? It is again getting cooled. It's very cold inside the freezer, right? So what is happening? The energy is that much energy as the particles got, because it is hot outside. The opposite is happening. It lost its energy because it is very cold inside the freezer. So what happens? The particles will again come closer and becomes tightly packed. So they change back again into solid. So the process by which a solid changes into a liquid on heating, which I explained right now, is known as melting. So when you are taking the ice or anything from the freezer and keeping it outside, it gains energy and gets converted into a liquid. The process by which a solid changes into liquid on heating is called melting. Just opposite of melting, what is happening in the case of freezing? The process by which a liquid changes into solid on cooling, that is the main thing, on cooling, is known as freezing. That means when you are keeping water in the tray in the freezer, what happens? It gets converted into ice. Why? Because there is less energy. Since it is very cold inside the freezer, the particles will lose the energy and they will become tightly packed, and then they are getting converted into a solid. So the process by which a liquid changes into a solid on cooling is called freezing. What is happening here? One state of matter is getting converted to another state of matter by heating or cooling. Here we learn two processes, that is melting and freezing. Now let us see the next. Here, boiling water in a vessel. When the water is getting boiled, what happens is that finally a stage will reach when the water starts to boil and you are not putting off the fire, that is continuously boiling. When it boils, it gains so much of energy so that the particles of the liquid starts vibrating and they will escape from that force of attraction and escape as a gas. In gas, what is happening? The particles will occupy all the available spaces and we can't see. So since it is covered with the top lid, only the water vapor can escape through this opening. So it is going out. That is known as evaporation. So here, when it is on heating, the liquid has changed into its gaseous form. that is known as evaporation. And when the gas which is escaping, when it is touching a cold surface, see the ice is kept on the lid. What is happening here? The evaporated, the water vapor which is coming out is coming in contact with this lid with ice over. That means it is a cold surface. Then it again gets converted into water. That is known as condensation. Let me explain what is evaporation. So now let me tell you what is evaporation, the definition for evaporation. The process by which a liquid changes into its gaseous form on heating is called evaporation. Here what is happening? When the liquid is getting heated up, the particles will gain so much energy and they will just escape and as water vapor to its gaseous form. That is known as evaporation. So many examples we can see in our daily life for evaporations. The water gets evaporated from the lakes and rivers during the summer season because of the heat of the sun. The water gets heated up so much that it gets evaporated into its gaseous form and just go into the atmosphere. That is also happening due to evaporation. When you put the wet clothes under hot sun, it gets dried up by the water present in the clothes is getting evaporated because of the heat of the sun. What is evaporation? The process by which a liquid changes into its gaseous form on heating. That is known as evaporation. Now see, what is happening next? As we learnt in melting and freezing, when the water is again, when it is getting cold, what happens? It again changes into solid. Here what is happening? The gas, when it is coming in contact with the cold surface, as I showed you in the picture before, the water vapor which is escaping from through that opening, when it comes in contact with a plate with ice, that means it is coming in contact with the cold surface, it gets converted into water again. That process is known as condensation. See, have you seen the dewdrops on the leaves in the morning, foggy mirror in the bathroom? All this is happening because of the condensation. This is what you can see. This is a result of the condensation only. So the process by which a gas change into a liquid on cooling is called condensation. From this, it is clear that one state of matter can get converted into another state of matter by heating or cooling. That means melting, freezing, evaporation, condensation. All these are happening because of the heating or cooling of the substance. So states of matter can get converted from one state to another state by heating or cooling. So now we already learned about the matter, the three states of matter and the change of the state of matter from one state to another by heating or cooling, that is melting, freezing, evaporation and condensation. So that is all over about that portion. Now let us move on to next section, another interesting section, how a solid is getting dissolved in a liquid. Many times we happen to see this in our life. See, your mother is putting sugar in the juice to make it sweet or putting salt like that. Why here all a solid is getting dissolved in a liquid. Now I am going to tell you how this is happening. Now see, what is this in my hand? I have a spoonful of salt. Okay, I am going to put this salt in this water. So what is this? The solid which I am going to add to this water. There is a name in science for this. That means the solid which you are going to add to a liquid, we call it a solute. Here what is the solute? Salt is the solute here. This solute I am going to put in this water. Then what is the water? The water is known as the solvent. So the salt which I am going to put in this water is called a solute, and the water in which the liquid in which you are putting the solute is known as the solvent. So when I am putting the solute into the solvent and I am stirring it, for why? Now this became, what is the name for this? This is not pure water or only salt. What is this then? We call it solution. What is it? Solution. The solid which I added to the liquid is called solute, and the liquid is known as solvent. When both comes together, we call it solution. Usually in science, when salt is getting mixed up with water, we say salt dissolved in water. Dissolve is the term which we use to explain some particles mixing with the solvent. Here what is happening? I hope it is clear. The salt with the solid which I added to the liquid is known as the solute, and the liquid is known as the solvent. So solute plus solvent gives you what? The solution, and this is salt water. This is a solution we call in science, and when you add something to another, we call it the salt dissolved in the water completely. So how can you dissolve water? By stirring, isn't it? That will come later. Now I hope it is clear. The salt which we are adding, the solid which we added in this water is the solute, the water is the solvent, and the solute plus solvent form the solution of the water. Now see, the same thing I have shown this slide also. Salt plus water, here this is salt, and when you are putting the salt in the water, it became the salt water, which is known as the solution. See what is happening? This is how the particles are getting arranged when a solute is mixing with the solvent. Here these are the particles of the solid. That means they have little space in between, they are very closely packed. When it is getting mixed up with the solvent, which is the water, what happens? It is green in color. I just picturization of this. Then again when they together form, they become the solution like this. What is happening here? The solute particles are getting mixed up with the solvent particles. That means they are occupying the space between the particles and they form the solution. This is how a solution is formed according to particle arrangement. See what is it? The solute plus solvent gives the solution. Now let us see once again what solute, solvent and solution is. The solid that dissolves in a liquid is called solute. This is what I showed you right now. The salt which I added in the water, here that salt is the solute. So the solid that dissolves in a liquid is called the solute. And what about the water or the liquid which I had in my other hand? The liquid in which the solute dissolves is called the solvent. So solute is the solid and the liquid is the solvent. Now what about solution? The liquid obtained after dissolving a solute in a solvent is called solution. So the liquid obtained after dissolving, when you are adding the solute to the solvent, the liquid which you are getting as a result, that is known as solution. So solute plus solvent will give you the solution. Now let us see the ability of a solvent to dissolve, how the ability of a solvent to solute to dissolve in a solvent can be increased. The ability of the solvent to dissolve a solute or the ability of the solute to dissolve in the solvent, how that can be increased. That means by stirring the solvent so that the solute particles are distributed evenly. When you stir, the solute particles which you are putting in the solvent will be distributed evenly so that it dissolves faster. The next is by adding the solute in the powdered form. When you are adding the solute instead of big cubes, if you are adding in a powdered form, the solute will get dissolved in the solvent more faster. Then heating the solvent, here also the same, the solvent particles will gain more energy when you are heating it and they come in contact with the solute particles, and so the solute will get dissolved in the solvent very fast, and so the ability of a solvent to dissolve a solute, or the ability, how much faster the solute can dissolve in a solvent can be increased by stirring the solvent so that the solute particles are distributed evenly. That means the surface is distributed everywhere in the same way. It is not constrained to a particular position or anything like that. If you stir it, it will be distributed uniformly. Then adding the solute in the powdered form, instead of adding big cubes, you can just find out if you add a big piece of something, it will dissolve in the solvent very slowly. But instead of that, if you are adding it in powdered form, it dissolves very fast. Then by heating the solvent, by heating also the solvent particles will gain more energy and they come in contact with the solute particles, which make the solute particles to dissolve in the solvent very fast. So now we already learned about this matter, the states of matter, and how one state of matter is getting converted to the another state of matter by heating and cooling, and how a solid is getting dissolved in a liquid. Now let us have a quick recap of what you learned right now. See, anything that has mass and occupies space is called matter. So all the substances which you see around that occupy space, and if it is having weight, it is known as matter. The matter exists in three different forms: solids, liquids and gases. Matter can change from one state to another by heating or cooling. Then about the mixing of the solute in the solvent. The solid that dissolves in a liquid is called the solute, and the liquid that dissolves in the solute is called the solvent. Liquid obtained after dissolving a solute in a solvent is called solution. So, I hope this chapter of states of matter, that means the matter, 3 states of matter, conversion of one state of matter into another, and how a solid is dissolving in a liquid. All these points are very much clear to you. That's all for today. Thank you.